Okay. So welcome back to my channel. And today we're going to do some math problems. So let's get into it. And today we're going to be focusing on, this lesson is called form follows function, right? So in reality, what are we going to be actually learning? So we're going to be able to use different forms of linear and exponential functions to efficiently write equations. So now again, we're getting back into the mix of comparing linear and exponential equations or functions, use the information given in different forms of equations to graph functions. And how do I use forms of equations for graphing linear and exponential functions? And what is the purpose of having different forms of equations? And how do I choose which form is the most efficient? So these last couple of questions here, or the questions that they actually pose here, are really good questions. So how do I know which equation should I be using? Which one is the most efficient? Why do we even have more than one equation? These are all really, really good questions that you should be able to answer by the end of this lesson. So here we go. So in our work so far, we have seen linear and exponential equations in so many forms. Some of the forms of equations and their names are, so the linear equation, we've learned linear, and we've learned down here is exponential, okay? So up here, we've learned about slope-intercept form. That's the guy that you've known since probably 6th and 7th grade, but really formally into like probably 8th grade. And then we have point slope form, which is what we just learned, y equals m parentheses x minus x1 plus y1, where m is the slope and x1, y1 are the coordinates, right? Where m is the slope, again, m is the slope, m is the slope. And B is your y-intercept. Again, your y-intercept is just a special point, right? And then it looks like this. And then your recursive formula, which you guys all really did well on, f of n equals f of n minus 1 plus some value, some constant difference, and then giving an initial value of f of a. And you had to make sure that you did that. So we either use f of 0, f of 1, whatever. So exponential functions, we had explicit form, which looked like this, a b to the x. And then we had the recursive formula, which was just your common ratio or constant ratio, whichever one you want to call it, times the previous number, right? So knowing a number of different forms for writing and graphing equations is like having a mathematical toolbox. You can select the tool you need for the job, or in this case, the form of the equation that makes the job easier. Any master builder will tell you that the more tools you have, the better. In this task, we'll work with our mathematical tools to be sure that we know how to use them all efficiently. As you model the situations in the following problems, think about the important information in the problem and the conclusions that could be drawn from it. Is the function linear or exponential? That's something that you guys are pros at, right? Does the problem give you a slope, a point, a ratio, a y-intercept? Is the function discrete? Is it continuous? This information helps you to identify the best tools and get to work. Okay, so there is a phrase that I want to say, which is really interesting, that someone said, I don't remember who said this, so I forgive me if I don't give credit where credit is due, but they said, if you only have a hammer, every problem starts looking like a nail, right? If the only tool that you have is a hammer, then every single tool every single problem that you see is going to look like a nail. Because, the hammer's job is just to like pound nails into wood or whatever you are building, right? But here we now have 1, 2, 3, 4, 5 different forms, different tools, right? So depending on what it is, linear or exponential, depending on what they give you, slope, the point, or whoever. Oh, really? Abraham Kaplan is the one who said that. Thanks. Thanks, chat. You guys are awesome. Okay, so depending on what that is, that's what I'm going to use. Okay, and that's part of being a really strong mathematician, is using the information in front of you to build what you want to build. So think about being a really good chef. I don't know, there's a bunch of those shows out there that they give you really obscure ingredients and you're supposed to make, a dessert, or you're supposed to make a appetizer. And based on the ingredients that they give you and the tools that you have available to you, that's your job as a chef, right? So same thing goes here. Yes, chopped, of course. So here, we are doing the same thing. They're going to give us information, sometimes obscure information, and we're going to use one of these tools to build something, to make something. Okay. So in his job as a cashier, Joe makes $500 each month plus $20 every time he convinces a customer to open a charge account at the store. So what happens? He makes $500 each month plus $20 every time he gets a customer to open a charge account. Got it. Write the equation that describes Joe's monthly income, I, as a function of N. I don't know what country Joe is living in. Good point. The number of accounts that Joe solicits. Name the form of the equation you wrote and why you chose that form. Okay, so let's just start off with this. So first, write the equation that describes Joe's monthly income, I, as a function of N, the number of accounts that Joe solicits. So how much is his monthly income? How much is Joe making every month? Oh my gosh. How much is Joe making every month? How can we write that as an equation? So first of all, your head should go like this. Am I in linear land or am I in exponential land? Yeah, very good. We are in linear land. How do you know that we're in linear land? What here tells you that we're in linear land? What here tells you that we are in linear land? We are not in, how do you know that we're not in exponential? It is a linear progression. Very good. You kind of do see the slope. Some of you are pointing out the word slope. What would our slope be? Be very careful, okay? Because there's a lot of slopes depending on what our question is. So it says, write the equation that describes Joe's monthly income, how much he makes in a month. Very good. Ooh, this is really good. This is a really good, I can't find my, hold on a second. Someone wrote, constantly adding and not multiplying means that we're in linear. Very good. This is an awesome distinguish. Like, this will help you determine what you are doing. Are you adding or are you multiplying? Adding tells me that I am in linear land, right? Versus multiplying, which means I'm in geometric. Oops, sorry, I should say exponential. Exponential. Okay, so very good. Okay, so here it says, write the equation that describes it. Very good. So what would my, no worries. Yeah, there is no constant ratio. Very good. You guys are like hitting all these major things. So I will say you've all grown a lot since we've started talking about exponentials, because the way you're talking about it tells me, the way you're able to pull out these differences between linear and exponential tells me you understand a lot. Very good. Okay, so how do I do this? Let's see. So what is your slope? What is your slope? Oh, so we can use whatever equation we want. Okay, so here's your question. Do you want to write it as y equals mx plus b? Do you want to write it as y equals m parentheses x minus x1 close parentheses plus y1? Or do you want to write it as recursive? And I'm just going to write recursive. Ooh, I can write recursive like this. Hold on. F of, oops, we're supposed to be using I. Hold on a second, guys. I of n equals to I of n minus 1 plus d. Which way do you want to go? Slope intercept? Recursive? What do you want to do? Yeah, it's you get to choose. Oh wait, look, we forgot all these questions. Okay, so here. So yes, you already figured out it's linear. Is this continuous or discrete or neither? Is this continuous or discrete? Very good. It is discrete. What told you that it was discrete? Yeah, it's point by point. Like there's no in-betweeners, right? So if you say that n is the number of accounts, right? So yeah, it's not a loading bar. Good job. So it's not a loading bar. Someone says, like kind of like loading, like downloading, like a progress bar on when you're downloading something. This is not that. He gets $20 every account, right? He's not going to get 2050. Very good. There's no such thing as 2.5 accounts. It's it or neither. Very good. So my preference is probably going to be this one, y equals m parentheses x minus x1 plus y1, because of the information that they gave me. Actually, y equals mx plus b actually makes sense too. Okay, so clearly here our slope is what? What is our slope? Where do you see our slope? Yeah, very good. It's $20 every single time. So this guy is our m. This is our m. Very good. So then what is 500? What would 500 be? Oh, okay. So if n is the number of accounts that Joe solicits, right? So he will make $500 if he gets, actually, you know what? Let me show you a table. If I show you a table, then you'd see why, why 20 is our slope. Oh, I did not want to do that. Hold on, please. Sorry. Let's put it right here. Table. This. Okay. So this is n, meaning, and this is the number of accounts. So num of accounts. And then this over here is his income. So if he gets 0 accounts, how much money is he making for that month? For the whole month, if he doesn't get any accounts. Yeah, he gets $500. Let's say he gets 1. Yeah, it's 520. Or how Miss Johnson likes to write it, right? He gets 500 plus 20, right? Versus if he gets 2 accounts, how much is he getting? 500 plus 2 times 20, right? Let me scoochy this over so you guys can actually see. No, stop it. Oh no. But I want this side to move. How do I get this? There it goes. There it goes. So this would be 2 times 20. Now, do we see why it's the slope? Yeah, because the 20, it's going up by 20 every single time. Very good. So what would 500 be called, guys? What would be 500 be called? Yeah, it's our B, isn't it? It's our y-intercept. Very good. So do you see, based on this example, why I would use this one or this one? Not this one. Okay. Can you write me your equation? Which one would you use? Would you use y equals mx plus b or y equals m parentheses x x1 plus y1? Which one would you use? Okay, I'm going to write mine as y equals mx plus b, y equals 20x plus, not 100, 500. So maybe Joe thinks like, if every single day that I work, I get 3 accounts, that's an extra $60 in my pocket, right? Very good. Now, Ms. Johnson, if I was to write it using the point slope form, would my equation look the same? No, it wouldn't, right? Ms. Johnson, if I do use it, which point would I use? I don't know. You could use whatever point you want. You could use this one with 2, what, 540? Yeah. Yeah. If you used 1, 520, so it wouldn't look the same, but the important thing here is that they would be the same. Value-wise, they would be the same. All right, so here's where we're going to end it for just today. So I hope that made sense to you all. Have a great day.